Hello everyone, my name is Mayur Vasoya. I am a second year master student in construction engineering and management at CEPT University. This presentation is my Studio 3 portfolio for integrated construction practice. And in this portfolio, I am presenting my learnings, my roles, and the work completed during the semester as part of the group. Our project focusing on understanding BIM integration, construction planning, scheduling, 4D simulation, 5D simulation, and overall coordination. So now move on the project. The project brief assigned to us is a co-working hub, which is an upcoming commercial building and consists of the one tower with three basements and a ground plus 11 floors. The total cost of this project is around 132 CR. The site spreads across 6,300 square meters and the total built-up area is about 4.8 lakh square feet. And the project duration is planned for 13 months. So starting from the 12th December 2024 and ending is the June 2026. Currently, the work progress is up to the roof slab of the second floor. The site is located in Vastrapur, Ahmedabad. It is well connected to the major transport hubs. Kalupur railway station is around 8.3 km away, and the Sardar Vallabhbhai Patel International Airport is around 13.4 km away. This proximity help is easy material movement, labor mobility, and access for the consultant and contractor. The main object of this studio was to understand integrated construction practices. Our scope included beam modeling, drawing, coordination, clash detection, scheduling, resource planning, 4D and 5D simulation, and learning how all these components connect during the actual project execution. In our group, I handled the two main roles. First, as the beam coordinator, I was responsible for preparing the beam execution plan, performing the clash detection, reviewing and updating models, coordinating between the disciplines, and preparing 4D and 5D simulation. Second was I worked as a plumbing consultant, where I created the LOD 300 plumbing model and resolved the claims related to MEP services. These roles helped me to understand and importance of collaboration and accuracy in BIM. So now move on the LOD and LOS. LOD stand for the level of development which define how detailed a beam model is. And LOS stand for the level of schedule which defines how detailed the construction schedule is. Both LOD and LOS need to be aligned so that modeling and scheduling support each other during execution. So level of development, LOD 100 represents the conceptual design, LOD 200 is schematic design with basic size and location, and the LOD 300 is the detailed design where shape, size, quantity and location are accurate. And LOD 400 contains the fabrication level information for GFC drawing, and LOD 500 represents the final as built up model with O&M details. In LOS 1 is the master schedule at the highest level, LOS 2 break is into major phases, and LOS 3 is the detailed schedule, and LOD 4 is the look at plan for short term planning, and LOS 5 is the daily or weekly work plan. This level help in contacting, tracking and correcting project progress. So now move on the MEA table. MEA table stand for the model element authority table and it clearly show the which consultant would be the responsible for the modeling of the different element for the project. Here we can see that the architect would be the author A, all of architecture element and other consultant are the user for this element and are marked U likewise. In moving on the LOD/LOS, this table marks the design development, the model element throughout the timeline. This table shows that the architecture LOD 300 model for the basement 1 and first floor was completed in week 4 and LOD 400 model progress is completion in week 14 and week 15. So synchronizes LOD and LOS help the project team work smoothly. When modeling details and schedule detail grow together, it reduces clash problems, reworks and time delays. It also allows better communication between the structural, architectural and MEP teams. This slide shows the LOD 300 mechanical model. At the level, duct size, pipe size, equipment position, and clearance are accurate. This model was used for coordination and clash detection with architectural and structural models. In 4D simulation, we link the beam model with the construction schedule. This allows us the visualization the sequence of construction and identify potential delay or clashes in activity. It gives better clarity to planners, engineers, and contractors. We are divided in three pores, pore 1, pore 2, and pore 3. This construction schedule, including all major activities related to the building structure. It shows the starting and ending dates of each floor work, including certain reinforcement, concreting, and curing. So now move on the 4D actual and plant simulation. For the first floor, the plant duration was 45 days from 9 July 2025 to 22 August 2025. But due to the multiple issue like material supply distribution, heavy rains, waterlogging, and boundary wall failure, the work was delayed by almost 99 days. Because the ground floor activities were not completed on time, the first floor work actually started on 15 October 2025 and was completed on 15 November 2025. This comparison between the plan and actual help us the understanding real life challenges in the project execution. In 4D use case, one of the major issue observed was the staircase core. Casting the full core together delayed the settling work of pore 3 because curing took longer. Using 4D modeling, we proposed splitting the core into two sub-pores. This allowed the team to start searching for pore 3 earlier. As a result, we save time and improve the floor cycle even during material delays. So now move on to 5D simulation. In 5D simulation, we combine quantity data, schedule data, and cost data. We perform earned value management to understand the financial health of the project. The values where EV is 21.86 CR, PV is 21.92 CR, and actual cost is 12.75 CR. The CPI value of 1.71 so that the project is cost efficient at this stage, and the SPI value of 0.99 so that we are almost on schedule with very minor delays. In From the simulation, we observed clear difference between the plan actual and earned progress. This helps us understanding the real cost impact of the delay and the importance of proper sequencing. By identifying critical issues early, we could adjust the plan and avoid bigger delays in the future. So, in conclusion, this studio helped me the understanding the importance of integrated BIM with planning and execution. Throughout the 4D simulation, I learned how sequencing impact the real site progress. Through the 5D simulation, I learned how delay affect the cost and how EVM help in decision making. And LOD and LOS together ensure proper coordination and reducing error. Overall, this studio improve my skills in BIM scheduling, planning, coordination, and problem solving, which are essential in the construction industry. Thank you for watching my portfolio.